Have you ever seen a car salesman slap the roof of a new car and say, "This bad boy has 300 horsepower," and thought, "That's so many horses and it's just a car. How many horses would it take to power something like the sun?" No? Just me? Well, I'm going to answer that question anyway. Hi, my name's Elliot, and what's the horsepower of the sun? Before we can answer this question, we've got to understand what a horsepower actually is. I'm sure I won't blow any minds when I say it's pretty much the power of a horse. The hint is in the name. But I might blow some minds when I say it's not really the power of a horse. What do I mean? Well, to explain, we've got to go back to the 1700s. Back then, the Industrial Revolution was just getting kicked off, which involved the first major commercialization of steam engines. To drive factory machines? No. To pump water out of flooded mines. Unfortunately, the first designs for steam engines were garbage, so most people didn't bother with them, and instead used horses. And it's important to note, when I say horses, I don't mean like modern day race horses. I mean draft horses, the big boys, the ones that stand taller than a human. Over the next 50 odd years, a few people made some improvements to the steam engines, making them slightly less garbage, but they were still pretty garbage. Enter Scottish engineer James Watt. What? Yes, that Watt. The same one in all your light bulbs. But we gotta put a pin in that for now, because it's not been invented yet. In the late 1700s, Watt designed a new steam engine that was leagues better than any previous design. Because the engine was so much more efficient, Watt's original plan was to take the royalties of 1/3 of the savings you'd get from switching to his design. This idea fell through for a few reasons, but the largest of them was that the majority of mechanical work being done was still using horses rather than engines. But this in turn gave him a new idea, and what has got to be one of the best examples of marketing in history. What about comparing the output of his engine to the output of a horse? Thus was born the horsepower. But wait, I hear the hypothetical version of you saying, "You said a horsepower wasn't really the power of a horse." That I did, and to explain why, I need to tell you how Watt determined what a horse's power was. Except I can't. There's a surprising number of conflicting accounts of how exactly he determined it, but the most common one is that he looked at a horse mill and calculated it based on how many rotations the horse could do in an hour, looking at the distance they would travel and how much force they would be exerting. The problem is, it's never stated how he knew how much force the horse was exerting, and it more likely than not was just an estimate. Regardless, the story continues, he calculated a number somewhere around 33,000 foot-pounds per minute, and rounded it to that for simplicity. So even in the most likely recounts of the story, there was a fair bit of napkin math being done by Watt. He was an engineer after all. This worked out in his favor because he sold the engines with the promise that a specific horsepower engine could replace that many horses. While a horse can output about 1 horsepower for a few hours, realistically it can't for a full workday. What was done at the time was they would have horses working the mills in 8-hour shifts, then give them time to rest while putting new horses in the mill. So Watt undersold his engines, knowing that they would be able to over-deliver on the promise of how many horses they could replace, meaning more happy customers. What this also means is that a horsepower is not the maximum power of a horse, it's just an estimated average. Horses can produce much more power in shorter bursts, with the highest recorded value being about 15 horsepower for just a few moments. So, for the question of how many horses does it take to power the sun, it really depends on the time frame you're looking at. If you want to have the power of the sun in the palm of your hand for a second, each horse could be outputting 15 horsepower. But, if you wanted to create some sort of Death Star powered by horses, and without the death, that would be outputting power 24/7, you'd need several times as many horses as horsepower so they could take breaks. Now earlier I said that Watt came up with a figure of 33,000 foot-pounds per minute, and you've probably been wondering what that means. It's just a measurement of power in imperial units, but we don't do that here, so let's return to that pin I put way earlier in the video and talk about the watt. The watt is the international standard unit for power, named after James Watt in commemoration of his achievements in physics and mechanics, but it was named a good 60 years after his death. Ironically, after being created by Watt, the horsepower became a pretty standard unit of power, especially for engines, but it's been largely replaced by the watt. Of course, there's never a smooth conversion between imperial and anything else. 1 horsepower equals 745.7 watts. So, how does that compare to the power of the sun? The sun has a power output of about 380 septillion watts, which is about 500 sextillion horsepower, or 500 with 21 more zeros behind it, which is a number as large as it is meaningless. If we wanted to have the horsepower of the sun for 1 second, we would need about 30 sextillion horses, but that's still far too large a number for anyone to make sense of. Let's try and contextualize just how large that really is. The volume of planet Earth is about 1 sextillion meters cubed, so if we make a rough approximation that each of these horses takes up 1 cubic meter, which isn't that inaccurate, the total space they take up is that of 30 planet Earths. And you're probably like, whoa, that's a lot of horses! But remember, this is for just 1 second of the sun's power output. If we wanted a constant power output of 1 horsepower for, say, 24 hours, assuming you're making the horses take shifts, The amount of horses you'd need would take up as much space as a few thousand Earths. And now you're definitely like, whoa, that's even more horses! But it's important to note that the Sun, in comparison, is about the size of 1.3 million Earths. So actually, the number of horses needed to output the power of the Sun would take up a much smaller space than the Sun itself. This is assuming they're all compressed into a big ball and completely ignoring the logistics of how you'd actually harness the horsepower and ignoring any losses. But regardless, this shows that horses are a more energy-dense material than the Sun. Thank you for coming to my TED Talk.